Welcome to my YouTube channel. Dhanesh here. So this is a video on electrostatics. See, in the last video we derived an expression for the dipole moment in the axial position. That's done. Dipole moment, the derivation in the axial position is done. So now in this video we are going to derive an expression for the the intensity of electric field. See, last video we derived an expression for the intensity of electric field in the axial position. This is what we have covered. Now in this video we are going to derive an expression in the equatorial position. So this is the figure for the equatorial position. So in this video I am going to derive an expression in the equatorial position for intensity of electric field. So you know what is an electric dipole? Two equal and opposite charges separated by a very small vector distance will constitute an electric dipole. You know it. And I know the dipole moment. See, another term we discuss here is the dipole moment. So what is dipole moment? It is denoted by the letter P, and P is equal to one of the charges Q into distance in vector form. This is the equation. Vector P is equal to Q into 2A. So these aspects you know. Now I am going to discuss, I am going to derive an expression for the intensity of electric field due to an electric dipole in the equatorial position. But in the axial position we derived the equation. I can tell you the equation we derived is E is equal to 1 by 4 pi epsilon 0 2p divided by r cube. This is the equation we derived for the axial position. And in the equatorial position, so let me derive the equation in the equatorial position. So first you have a look at the figure. See, here you have two charges. This is the plus q charge and next one is the minus q charge. Minus q charge is on the right side, plus q charge is on the left side. 2a is the separation between the charges. Here 2a is the separation. Normally we take it as 2a, and p is a point. See, here you have the point P. It is at a distance r from the center of the dipole, and that point is in the equatorial position. P is this point. This is the point P. So we need to find out the intensity of electric field at P. See, at P there are two electric fields. One is the electric field due to plus q charge, and another one is the electric field due to minus q charge. You always know the electric field towards the minus q charge will be towards the charge, and from the plus q the electric field will start. So from the electric field always starts from the positive charge and ends on the negative charge. You know that. So E of plus Q, the direction it is given here, I marked it here. This is the direction of E of plus Q. It's correct because it starts from the positive charge. E of minus Q, the direction I have given here, you can see it here. This is E of minus Q. It go towards the charge. And if you see the distances, the towards P from plus Q and minus Q should be same, and it would be, I can tell you, it would be by the Pythagoras theorem, it would be root of r square plus a square. This distance will be half of a, right? So this distance will be half of 2a, and it should be a. So the distances towards P from plus q and minus q should be, by Pythagoras theorem, it would be root of, you can write it as root of r square plus a square. This is the distance towards P from both plus q and minus q. So since both these charges are equidistant from P, the magnitude of these vectors E of plus Q and minus Q should be same, but the direction is different. So I can take it as E of plus Q is equal to E of minus Q is equal to E. It should be same. The magnitude should be same, and this E should be, if you take it, is 1 by 4 pi epsilon 0 into P divided by R square. Then it should be R square plus A square. Am I right? It should be the square of root. It would be R square plus A square. So this is the magnitude of intensity of electric field. It should be same. But the problem here is its directions are different. In the axial position, they were in the opposite direction and we just subtracted it. Here, they are not in that way. See, it's the directions. When I want to tell you, so this is an isosceles triangle. The P is equidistant from the, since it is in the axial position, P is equidistant from plus Q and minus Q. For an isosceles triangle, the base angles should be equal. So this angle also should be theta. This angle also should be theta. I am taking both as theta. Then by the properties of triangles, and these two parallel lines and this diagonal, so this angle should also be theta, it, and this angle also should be, these two are parallel lines, this is diagonal, and both those angles should be theta. From this, what we can understand here is I am resolving E of plus Q and E of minus Q, magnitude is equal. I am resolving E of plus Q and E of minus Q. So the resolution, the component near to theta is cos component, and this should be sine component, right? This should be the sine component. This should be sine, and here also you will get on sine component. So the sine components will cancel each other, and the cos components, you will get two cos components. This is E cos, that E of plus Q, one component will come E of minus Q, so you will get 2E cos theta there. So that is the resultant electric field there. You understood? So the resultant electric field at P, when you resolve the vectors E of plus Q and E of minus Q, the sine components will cancel each other and the cos components will add up. So you will get 2E cos theta. The reason is E of plus Q and E of minus Q should be equal. That's why I have taken it as E. The magnitude is equal. So 2E cos theta. So the resultant electric field, I can write it as E is equal to 2E cos theta. And what is E here? 2 into 1 by 4 pi epsilon 0 into P by R square plus A square. What is cos theta here? Cos theta will be opposite side by, cos theta is adjacent side by hypotenuse. That is adjacent side, this side is A, this side should be A. So that is, adjacent side by hypotenuse is root of R square plus A square. I told you this hypotenuse, this is the hypotenuse. So that one will be, this is A. So that you understood. Now cos theta is any triangle you can take from there. When you take it, it is A by root of R square plus A square. Now I will simplify this. For that I can tell you this one will be, one second. So you can write it as, so in the numerator 2PA, this is A, this is not Q. You need to understand, so some mistake I made, sorry. See, this is 2 into 1 by 4 pi epsilon 0. This is Q actually. This is the charge, right, for intensity of electric field. So this one should be Q. So I am writing it as Q here. This is 2 into 1 by 4 pi epsilon 0 into Q by R square plus A square, and this is A. This is, you can understand it. This distance will be A. This is A, the distance here from the triangle cos theta. See, this is for cos theta. This term will be for cos theta. See, this is 2, and this term is for the intensity of electric field. 1 by 4 pi. This is E. Right? So you understood. 1 by 4 by epsilon 0 Q by R square plus A square. Now what is 2QA? That is 2A into Q. It is the dipole moment. So I can write it as E is equal to, here E is equal to 1 by 4 pi epsilon 0 into dipole moment. This is r square plus r a square the whole raised to 1. This is r square plus a square the whole raised to half. Root means half by the law of exponents. 1 plus half, 3 by 2. So I can write it as r square plus a square. I can write it as r square plus a square the whole raised to 3 by 2. So you got this. Now we will take one approximation. You know that here the r is very much higher than, that's the approximation we take. R is very much greater than A. A is half of the length of the dipole. So when you neglect it, the equation becomes E is equal to 1 by 4 pi epsilon 0 into P by, so this becomes R square the whole raised to 3 by 2, it is P by, you can write it as R cube. So this is the equation, 1 by 4 pi epsilon 0 into P by R cube. So this equation, if you analyze for the axial position, you got it as 1 by 4 pi epsilon 0 into 2p by r cube. So for the equatorial position, half of that. In 2017, the common entrance test, they asked about the relationship between the magnitudes of the intensity of electric field at the axial position and equatorial position. So you can see it here. It is the magnitude of intensity of electric field in the equatorial position is half of the axial position. So you can write it as E equatorial is half into E axial. That means E axial is 2 into E equatorial. So that's another important point. You need to keep it in mind. So that's all about the derivation. We have covered both the derivations, both axial and equatorial, for the dipole moment. Thanks for watching. Please subscribe my channel. We will be providing more videos on electrostatics. Thanks a lot.